Hi everyone, for the continuation of the solid waste engineering, now let us discuss the disposal by sanitary landfill. So a sanitary landfill is a land disposal site employing an engineered method of disposing of solid waste on land in a manner that minimizes environmental hazards by spreading the solid waste to the smallest practical volume and applying and compacting cover material at the end of each day. According to the Environmental Protection Agency, modern landfills are well-engineered facilities that are located, designed, operated, monitored, closed, cared for after closure, cleaned up when necessary, and financed to ensure compliance with federal regulations. So others, however, believe that these views provide a false sense of security. Some believe that groundwater contamination by landfill is inevitable, that the landfills will require periodic maintenance in perpetuity, and that we are simply transferring the economical and public health burdens associated with disposal of municipal solid waste to future generations. Now, for the site selection, it is perhaps the most difficult obstacle to overcome in the development of a sanitary landfill. Opposition by local citizens eliminates many potential sites. In choosing a location for a landfill, consideration should be given to the following variables: restricted locations such as wetlands, floodplains, and seismic impact areas, public opposition, proximity to major roadways, load limits on roadways and bridges, underpass limitations, traffic patterns and congestion, location of the groundwater table and sole source aquifers, soil conditions and topography, availability of cover material, climate such as the floods, mudslides, and snow, zoning requirements, buffer areas around the site, the high trees on the site perimeter, location of the historic buildings, endangered species, and similar environmental factors. Now, for the operation of landfill, the most commonly used method of operation at sanitary landfills is called the area method. The area method uses a three-step process: spreading the waste, compacting it, and covering it with soil. In the area method, the solid waste is deposited on the surface, compacted, then covered with a layer of compacted soil, called the daily cover, at the end of the working day. Use of the area method is seldom restricted by topography. Flat or rolling terrain, canyons, and other types of depressions are all acceptable. This is a profile view of a typical landfill. So as you can see, the waste and daily cover placed in a landfill during one operational period form a cell. So the operational period is usually 1 day. So the waste is dumped by the collection and transfer vehicles into the working phase. It is spread in 0.4 to 0.6 meters layers and compacted. At the end of each day, cover material is placed over the cell. The cover material may be native soil or other approved materials. The recommended depths of the cover for various exposure periods depends on the amount of waste. The dimensions of a cell are determined by the amount of waste and the operational period. A lift may refer to the placement of a layer of waste or the completion of the horizontal active area of the landfill. As you observed in the figure, a lift is shown as the completion of the active area of the landfill. The first lift is called a fluffy lift because the waste is not compacted until 2 meters of waste is deposited. This is done to prevent damage to the liner as a result of a heavy compaction equipment. An extra layer of intermediate cover may be provided if the lift is exposed for long periods. The active area may be up to 300 meters in length and width, so the trenches vary in length from 30 to 300 meters with widths of 5 to 15 meters. The trench depth may be 3 to 9 meters, and the benches are used where the height of the landfill exceeds 15 to 20 meters. So they are used to maintain the slope stability of the landfill, for the placement of surface water drainage channels, and for the location of landfill gas collection piping. Now, the final cover is applied to the entire landfill site after all the landfilling operations are complete. A modern final cover will contain several different layers of material to perform very specific functions. So that's for the landfill design. And now let's move on to the environmental considerations. Now, disease vectors and water-air pollution should not be a problem in a properly operated and maintained landfill. Good compaction of the waste, daily covering with a good compaction of the cover, and good housekeeping are must to control flies, rodents, and fires. Burning, which may cause air pollution, is never permitted at a sanitary landfill. If accidental fires should occur, they must be extinguished immediately using soil, water, or chemicals. Odors, dust, and wind-blown litter can be controlled by covering the waste quickly and carefully, and by sealing any cracks that may develop in the cover. Now let's discuss the liche, liquid that passes through the landfill, extracts dissolved and suspended matter from the waste material. The liquid enters the landfill from external sources such as rainfall, surface drainage, groundwater, and the liquid in and produced from the decomposition of the waste. Solid waste placed in a sanitary landfill may undergo several biological, chemical, and physical changes. Aerobic and anaerobic decomposition of the organic matter results in both gaseous and liquid end products. Some materials are chemically oxidized, and some materials are dissolved in water percolating through the fill. This is an example of a liche, and to calculate for the quantity of liche, let us discuss this step. The amount of liche generated from a landfill site may be estimated using a hydraulic mass balance for the landfill. Those portions of the global hydraulic cycle that typically apply to a landfill site include precipitation, surface runoff, evaporation, transpiration, infiltration, and the storage. So it's delta S is equal to the precipitation minus the evaporation minus the runoff plus the infiltration minus the percolation from landfill. Precipitation may be estimated in the conventional fashion from climatological records. Surface runoff or run-on may be estimated using the various engineering techniques that are beyond the scope of this book. And the evaporation and transpiration are often lumped together as the Evapo Transpiration. So that's the letter E. Transpiration data may be obtained from plant science textbooks and other sources, from direct measurements, and from modeling efforts, while the infiltration may be estimated using Darcy's law. Now the Liche collection. The Liche collection system must be designed so that the depth of Liche above the liner does not exceed 0.3 meters. The Liche collection system is designed by sloping the floor of the landfill to a grid of underdrain pipes that are placed above the geomembrane. A 0.3 meter deep layer of granular material, such as sand with a high hydraulic conductivity, is placed over the geomembrane to conduct the liche to the underdrains. So in addition to carrying the liche, this layer also protects the geomembrane from mechanical damage from equipment and solid waste. In some instances, a geonet, which a geofabric protective layer to keep out the sand, is placed under the sand and above the geomembrane to increase the flow of liche to the pipe system. And for the last topic, the liche treatment. The composition of landfill liche varies greatly, but is generally highly contaminated with ammonia, organic contaminants measured as chemical oxygen demand, and biological oxygen demand, halogenated hydrocarbons, and heavy metals. In addition, Liche usually contains high concentrations of inorganic salts, mainly sodium, chloride, carbonate, and sulfate. So thus it must be collected and treated before discharge. Liche from young landfills with large deposits of municipal waste, for example, will often contain very high concentrations of ammonia and organic chemicals. So in contrast, Liche from old landfills will have high salt concentrations with distinctly lower ammonia, heavy metals, and organic chemical concentrations. In some cases, the collected Liche is sent without any pre-treatment to municipal wastewater treatment plants where it is treated along with municipal wastewater. In other cases, the collected Liche is pre-treated by chemical flocculation, followed by sedimentation and filtration before it is sent to the municipal wastewater system. So that's all for this week, and I hope you learned something. Thank you, and have a good